Morning, everybody. This is Cassie Strumo. I am the marketing specialist here at EAC. We'll start off today with an introduction of EAC, and then I'll be handing things off to Shannon Wilson, who's also from EAC, who will present on Creo Simulation Live. Then Emily Pinto from PTC will be showing us a preview of how real-time simulation works. Everyone gets a recording after the session, pending any technical difficulties. And then if you do have any questions, just put it in our Q&A and we will answer them after the presentation. So at EAC, our mission is to transform the way companies design, manufacture, connect to, and service their products. We are not only a value-added reseller for PTC, but we are the #1 solutions provider for PTC in the country, with experts in 22 areas of product development. And we're located all over the U.S. with our headquarters in Minneapolis. We offer our customers everything they need for product development, such as Creo CAD software for product design, service lifecycle management software for managing service documentation, and software that helps you manage your product data, such as Windchill, ThingWorx Navigate, and our customizable EAC productivity apps. We implement the Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. We also assist with design and engineering projects, like FEA, simulation, reverse engineering, and proof of concepts for our customers. We offer webinars and PTC certified training courses for continuous learning as well. We are also a commercial reseller for Formlabs, offering their latest products in additive manufacturing. The Form 3 is now available with packages starting at $34.99. Please keep us in mind. We have the solutions to help your organization save time and money throughout your product development process. So thank you for taking that time to listen to who we are. I will hand things over to Shannon so she can get started.
Great, thanks, Cassie. So the product development companies and teams we speak with every day are striving to achieve improvements in these areas, as well as looking for a better understanding of how their product performs in the field. From this list, what do you feel is your team's primary focus, day to day or even week to week? Let's look at the typical product development process and see where we might be able to make a genuine improvement. Everyone here is comfortable with this depiction of the traditional product development process. For many years, the industry has tried to consistently use simulation as part of this process for all the reasons we just reviewed together. Unfortunately, the fact remains that when simulation is used as part of the product development process, it's used exactly as you see it here, as almost a final validation step after the design is practically complete. It's not exactly the vision of simulation-driven design the industry has been striving to achieve for years. So why is that? What are the barriers to simulation being used every day throughout the development process and by design engineers? Often, engineers feel like they don't have the expertise they need to run simulations while they design. They feel like they need to consult an expert they may not even have access to. Often, the expert's initial task is to figure out how to simplify a copy of the design model so that the simulation will run in a reasonable time, but still provide an actionable answer. Engineers don't feel comfortable making this judgment. Additionally, we can all agree that the design process is an iterative one. Certainly, the design engineer would want to use simulation as he or she evolves the design throughout all these iterations. But this would require running a simulation that could take hours on multiple uniquely simplified copies over and over again. It's just not efficient and too disruptive to the design process. And because of this, design engineers just generally don't do it. This is the reason PTC partnered with ANSYS with the overarching goal to remove these barriers for product development teams. We're bringing together two leaders in their respective fields and delivering a single solution for our customers. We're going to remove the barriers we've just referred to. So what product development teams really need is a simulation tool that is so fast, so responsive, so simple to use that it can literally keep up with the design engineers every step of the way. No copies, no waiting, just simulation results right there throughout. A set of simulation capabilities that can be pervasive across the concept and detailed design stages of the process. Our new partnership with ANSYS gives us the opportunity to deeply integrate their breakthrough technology into Creo and make this need a reality. This new product is called Creo Simulation Live. This is the solution that gives every design engineer what they need to truly achieve simulation-driven design. The ability to instantaneously understand how design changes impact product performance is truly groundbreaking and only available with the solution that we're bringing to market in Creo. It uses a unique technology approach to deliver simulation results interactively as you design. This solution will complement our existing simulation offerings that focus more on the analyses that require higher levels of fidelity or are used as a final validation step. Let's call them the more traditional analysis that teams might currently use, represented here by our Creo Simulation extension that could just as easily be an ANSYS offering. Now let's take a look at Creo Simulation Live in action. I'll pass things over to Emily so she can show us what it can do.
Thanks, Shannon. So hi, I'm Emily. I work for PTC in the Virtual Center of Excellence, and today I'm going to show you a demonstration of Creo Simulation Live. We're going to start with the structural analysis. So here we see our snowmobile assembly, our Polaris snowmobile assembly. This is a full data set, so very complicated. It's not perfect. You still have some bolts and interferences here. So we're going to look first at a part of this, how we use CSL there, then move back to the assembly level, and then I'll demonstrate the modal and thermal analysis as well. So here, let's start by looking at this cast iron chassis. And we can zoom in to see that, we have a material already chosen, but we're going to need to start our simulation. So the first step is to choose between structural, thermal, and modal. Here we're going to choose structural. We see it pop up in our simulation tree. So first thing we have to do is set our constraints and loads. And this is very easy. We just select the surface that we want to add our constraint to, and similarly with the loads, we can choose which kind of load we want to put on it. We can put it on whichever surface that we need to. So here we'll set our force components, and we can do magnitude and direction, and of course change our units. And as we do this, we see these show up in the simulation tree over there under structure 2. So the way this works is if you set up a lot of simulations, all with different loads and constraints, maybe you have a thermal or a modal, and you can toggle between those as you need to. So setting this up, you're going to be able to use this later on. You're not, going to be stuck to use it just now, just like Creo Simulate if you use Simulate at all. So let's add another force. We have here 3 surfaces with the same force load on it, so we can select the 3 of those at the same time, save a little bit of energy, and enter in our force components and units. So this is the extent of what you need to do to set up a simulation. We've come in, to our part. We might have just been in the modeling tab. We hop right over to our simulation tab with these tools, put on our loads and constraints, and then we're ready to go. You'll notice that there was no simplification. We don't have to take time to reduce all of these little rounds or anything. And it'll auto mesh for you, and it'll run it no problem in just a couple of seconds. So here we're going to hit simulate, and you can see just how fast these results pop up. So in a matter of maybe 5 seconds, we're already ready to view our result options. We can see here the von Mises stress. If we click on our result options button, we can see that it's the von Mises stress displayed graphically on our part. We have our legend in the right, and we're able to see the units there as well. So what this does is this gives you a really good idea of how your design is going to behave, what kind of loads and stresses and displacements are going to be in it. And this is going to act as a guide for you to move forward to say, do I need to do more work here? Did my idea go as well as I thought that it would? Or am I ready to move on? Is this a solid part that I can move on with my work? So let's first look here at the result types. We have normal stresses, shear stresses, principal reaction forces. We're going to look at the deformation. This is a fun one because we can animate it. So we have some extra options for deformation. Here we can see the animation. This is our exaggerated view. If we want to get a little bit more of a true to life idea, we can check our true deformation box. And then we have to zoom way in and we can see, what that will actually look like. So the point of CSL here is to act as a guide, to guide engineers forward, let them know, are there issues popping up as they're designing it. You have that traditional analysis stage that typically you have to make a lot of design decisions before you can see how it all kind of culminates, in your design and how it's going to behave in that analysis. The idea with CSL is that it runs here in the background while you're designing, and so that it gives you a good idea of how your part's behaving long before you make, long, big design decisions. So we'll see what that looks like. We'll come back into our von Mises stress. We'll change our units over. So, this kind of wraps up the basics. We've come from our modeling tab. We've started the simulation. We've set it up. We've run it, and we've viewed the results, the analysis results. So now let's look at how you're going to actually use that in your design process to really get the value from this product. So we can zoom in. We see we have a maximum there. And we want to see a little bit more information. So we can click a simulation probe and put it there, just, to make sure that our stresses are where we want them to be. If the legend can be, a little bit more vague. So we can see that we have von Mises stress is about 55 megapascals. Well, right off the bat, we could tell that's too high. I don't think that'll pass the final validation, or, that's too high. I think that we could do better. I think that there's the stress here should be a little bit lower. So we're going to start by making some edits, and we'll see that we're using flexible modeling, but you can use whatever tools you usually use to design. And when we hit accept, we're going to see it update in the background automatically. So as that design change is accepted, we can see that our stress has lowered to 52 megapascals. So, okay, great. That's the direction that we're going for. It seems to be working, but I don't think it was quite enough. So maybe you want to make some other changes. Again, if you model parametrically here, you can model however you typically do. You have your full modeling environment. You can go back over to your model tab or your tools or wherever you want to go. But now you're able to see, after you've made those changes, okay, my stress here is 49 megapascals. That's perfect. That's right where I want it to be. This isn't going to give me any trouble later on. I'm not going to run into any issues with having to go back and fix this rib later in the design process. So that's really the idea. So we can move on now, confident that we've made a really quality part and that rib is really optimal for where it needs to be. So we can see our maximum stress has changed down into that arm. So talking about another extension that works really well with CSL, we have our design exploration extension. So what this does here is this will open a design exploration session. And this is a tool for helping you manage different versions of your model. So, CSL is all about informed engineering. You're informed early in the design process, optimizing, making the best quality parts, trying out new ideas and seeing the effects. And so design exploration session is about all of those same things as well. So they work really well together. So what it does is it brings in this entry checkpoint, which is your model when you've opened the session. And then you're able to make changes to your model, make design changes, and save them off as different checkpoints as you go through. So if you have a bunch of different ideas and you don't want to create a bunch of different files, all branching off each other, you can do that here in the checkpoint tree, and then you can toggle between them and see all the different ways that you've gone, all the different versions of your product that you could make. So, let's say, for example, we want to reduce that stress on the rib a little bit more. We have a new idea. What if we added a trajectory rib? I haven't done this before, maybe, but let's see what it does. So first, let's put a simulation probe. We think, our concern is that maybe the stress in this center section would be too high if we put another rib in. But with CSL and with our design extension, it's not going to take much time for us to try out this idea. So however you normally model, we're just going to put in a rib, and pretty soon we're going to be able to see those results. So not only can we see what it looks like with a new rib, but because it updates for us, we can see actually what the stresses are, what that RID did to the behavior, to the performance of our model. So this is really valuable information. You can try out some new daring ideas and see right away, are they working, are they not working? And you can make sure that your part is really optimized, really the highest quality products that you can make. So again, just guiding your engineer. If you want to save this as a checkpoint, you can review it later, maybe in a design review, or you want to go in a different direction and try out a different change, or we can save it and review that session later, or we can exit out like I just did, and we can see that the changes haven't been saved to our official model. So there's no risk of losing this official version, the version we came in with. And that's really the great thing about design exploration, is it can keep track of all that for you. So let's move back into our assembly level. We'll look at the structural simulation here. So this is going to work the exact same way. So structural on the part or the assembly level, CSL doesn't really care. We can see that we already have a simulation set up. So we have some constraints and we have some loads already placed on our model. And this will run just like the part level did. It might take a couple extra seconds because it is this huge assembly, but you'll see it's so much faster than traditional analysis, and that's for a lot of reasons. It also auto meshes this whole thing without simplifying. So there's no simplification that needs to be done. This isn't a perfect model. Of course, there's issues with every large assembly. And CSL doesn't really care. CSL is going to be able to auto mesh this. It does treat it as a whole bonded assembly. So you're not going to be able to see interactions between parts. Small gaps are going to be closed. But that all kind of goes in line with how this is used as a guide, not as that final step. So here we'll click simulate, and we'll see, excuse me, in just a couple seconds, we have our model, with the analysis already displayed on it. So our result options are the same. We can look at a different rendering method if we want to. We can see here that our max value is still right there in that piece we were looking at earlier. And our deformation. So let's see how our model is going to behave, get a good idea for what this is going to do in real life. We can see that this front corner has quite a large deformation. And at this point, then you can take that information and do with it what you want. So here in this example, we're going to bring in some suppressed parts and see how that helps. So we're going to put a simulation probe so we know exactly what's happening while we make these changes. And you can make any kind of design change. You don't have to bring in suppressed parts or suppressed subassembly. You can alter parts right from the assembly level if you want. But this is a really great way to check how well your design's working. So if we built this apparatus to keep the deformation, to reduce it, and we want to see, is this effective at doing what we want it to do? So we'll watch the deformation as it updates. And we can see already here, our deformation has dropped to 0.3 millimeters. So that's a pretty good indicator of whether or not our design's going the direction we want it to, or if we need to do more work. So again, getting you through that final step, that final validation analysis, that analysis that's so refined and takes so long to run. By the time we get there, we're going to know that everything is running the way that it should be. There are not going to be any surprises. It's going to pass that validation step the first time we get to that analysis. So getting our products out faster and at a higher quality. So let's look at the modal now. Again, it's very similar. They're all very simple to set up. A little bit different here. We're going to set the constraints in the same way, just choosing the surface that we want, and then using our little menu here to select OK. But our loads are different. So with modal, we're not going to add the loads like we did in structural, but we can look at the difference in our assembly, before and after we put in this subassembly. So let's take that out and let's hit simulate. And again, even with this whole large assembly, we can already see the results up and running. And these are very accurate results, by the way. They're just a couple percentage points away from the accuracy of other simulation tool, traditional analysis tools. The difference here is that these are it's a little bit more simplified controls, so it can be fast, it can be efficient, it can be easy for engineers to use who don't typically use analysis to work in the background to give them that information while they're working on it. So we'll look at mode 1. We can see our deformation up here is about 60.7. If we animate that, we can see what it looks like, giving a good idea of how this part's going to move. Then we can go check mode 4. Again, you have modes 1 through 6. So, whatever it is that you want to look at, you're going to be able to do right from this display, results display window. So now that we know what it's going to do here, before we add those parts in, let's bring them back and let's see the difference. Let's see what it does. So right away, it's already updating. We didn't even have to, select anything. We've just brought them in, and we have our results. Our options, you can see we're looking at mode 4, and our deformation, is quite different. We animate it, we can see that, the effect of that. It's pretty obvious. And then when we go back to mode 1, we're going to see, what does this do? What does this do to the front of my part? Well, that's even more different. That's a big, that's a very big difference from before we had this subassembly. And so, if this is what you like, if this is going well, then you'll know that. And if not, you're going to be able to make that decision. So let's move now into the thermal. So we have pulled up here our thermal. We have an engine to run a thermal analysis on. So if we come into our simulation tree, we'll see our constraints and loads. We already have some boundary conditions set here. We have a convection coefficient and a bulk temperature, and it shows you on your model, kind of graphically what it is that you've selected, so you can have an idea of if you've set your conditions correctly or not. And then you can change your units, of course, and then we'll add our loads. So we have a heat flow or a heat flux, depending on your situation. So we just choose the surface we want to apply it to, enter in our magnitude, choose our units, and we're ready to go. So no simplification here either, just ready to roll right out of our modeling tab. Let's hit simulate, and we can see our results are already complete. So this one ran even faster than the structural, it looks like, and we have all of these great, bars that show us which temperature zone we're in. Of course, we can change that. We can change the result type. We can look at, different rendering methods. We can look at composite or inverse surface, or just the surface if we want to know surface temperature. We can play around with the legend a little bit too if you need to, dragging those bars if you want the red zone all above, 130 degrees or something. You can pull that bar down, and it makes it very easy for you to see your maximum and minimum values. So I hope this gave you a good idea of what CSL is used for, how it's useful, kind of how to run it, and what's kind of involved in that. I can bring up, come back into our PowerPoint slides, and I can pass it back over to Shannon.
Great, thanks so much, Emily. So just to cover a few points on the product capabilities, Creo Simulation Live will enable you to gain and understand the impact on your design or product as fast as you make those changes. It will deliver this with speed, providing instantaneous results as you make design changes, just as we saw in the demonstration. It's also very easy to use. You saw how simple it was to set up and run the model and start seeing those results. It runs truly integrated within your design environment. No exports, no copies, no extra files, just see, design, and gain insight as you work. And of course, it's interactive, so there's no waiting for the simulation to complete after you've decided on your changes. It will support both structural, thermal, and modal. We're also focused on linear problems. So why Creo Simulation Live? You'll remember at the start of this presentation, we outlined several areas that customers have indicated they're trying to address and improve. As you can see from what this solution can do, we can support all these efforts by creating a deeper integration of simulation into the product development process, ensuring that every decision you can make be guided and done so quickly to ensure that you can keep up with the speed of design.
Awesome. Thank you, Shannon. And thank you, Emily, for that demonstration. I just want to remind everybody that Creo Simulation Live is the best simulation tool on the market. Please reach out and we'll give you access to the free trial. You can let us know when you want to speed things up with faster simulation. You can find our upcoming webinars on eacpds.com/events. Or if you'd like to see any previous webinars to date, go to our webinar replay library to watch them. Thanks again for coming on today, everybody, and have a great rest of your day.